boys and girls. It's good to see you again. Mr. Cameron asked me to make 3 short videos about geometry for the assessment you'll be having later this week. So this is part 1 today, okay? And that's to talk about points, lines, segments, rays, angles, and protractors. A point is a location in space. If we wanted to call it something, we could call it point P. This point on my neck is also a point. This point on the paper is another point. They are all locations in space. Then there's something called a line, which is a series of points. Notice how it's drawn. There are arrows on either end, which means the line goes on into infinity in both directions. If we wanted to name that line, we would say, we put the little line sign above it, line AB or line BA. They're the same line. Then there's such a thing as a segment. A segment is kind of like a line, except it stops. It has endpoints, okay? And it could be named the same way a line. Line segment CD or DC. Remember, that does not go into infinity. It has endpoints. Then there's such a thing as a ray. It's also a series of points. It starts at one point, in this case P, but then there's an arrow on the other end, which means it goes on into infinity. Now, if we wanted to talk about ray PQ, we would write a little ray sign above PQ. Notice the P comes first. That's very important. Think of sunshine. Rays come out of the sun, not into the sun. So the end point must always be first. In this case, ray PQ. Then there's such a thing as an angle. An angle happens when 2 rays come together at a common point. If you can see this little angle here, we can name it angle ABC. Angle CBA, or in this case, because it's a freestanding angle, we can just call it angle B. It's the opening. The angle is the opening that is made when 2 rays come together at a common point. And we call that common point, we'll talk more about it down here, a vertex. Okay? Then we have a protractor. Please excuse my drawing. I tried to do the best I could. If you have one at home, you can see it better. All it is a tool to help us measure these openings, these angles. Okay, and if you look at it carefully, there's usually a little hole or a little dot in the middle. Okay, that's the center point. There's a 0-degree line, a 90-degree line, and then a 180-degree line, and then there's lots of little lines in between. Those are all called degrees, okay? And they usually go by tens, okay? So that's a protractor used to measure angles. For example, if I put a ray, a line, or a segment on 0, one of my rays on or lines on 0, and then another line pointing upward toward 90, I just made myself a 90-degree angle, okay? Because you count from 0 to 90, there's your 90-degree angle. Half of 90 is 45, so if I move my ray down there, now I've just made an opening of 45 degrees, or a 45-degree angle. We'll talk more about that in a minute, okay? So let's take this for a minute. Now let's go back to rays, lines, and segments for a second. Okay, all rays, lines, and segments can be parallel. Okay, what that means is that they run side by side, the same distance apart. In this case, because it's a line, forever. They would never touch. Segments can do the same thing, rays can do the same thing. The important thing to remember is parallels the same distance apart. Think of a sidewalk. The top part of a sidewalk, bottom of the sidewalk do not touch. They are parallel. Now, they could also be perpendicular. Perpendicular means they could make a cross, or in this case, an upside down T. Notice I put that little red box in there. What perpendicular lines do is they make 90-degree angles, which I just showed you a minute ago. It's got to be a perfect cross, or an L, a T, to make a perfect cross. Those 2 lines are perpendicular. Then intersecting is just a plain X, no particular degree. We'll talk more about that in later chapters. Then there's something called skew lines, which we'll talk more about next year. They're neither parallel nor perpendicular. They're in what we call way different planes. But don't worry about that on this coming week's test. Let's go into angles again just for a second. Remember, I showed you that if I put a line or segment or a ray, one on 0, one on 90, I've just made a 90-degree angle. So a right angle is a 90-degree angle, okay? Now anything greater than that the opening greater, in this case I did it at 135, that's called obtuse. Think of obese, fat, big. That angle is bigger than 90 degrees, and that's the greater than sign. So an obtuse angle is greater than 90 degrees. Now, an acute angle, I'm kind of going backwards here, is anything less than 90 degrees. Okay, in this case, it's a 45 degree opening. 45 degree angle is less than 90 degrees. So those are the definitions of acute, less than 90 degrees angle, obtuse angle, greater than 90 degrees, a right angle exactly 90 degrees. And again, remember, the vertex is that hole in your protractor where the two rays or lines or segments come together. Now, another thing quickly, and then we'll end for today. When two angles, let's start with this one, equal 90 degrees. In this case, I've got a 45. And notice if I put another line right here, I'd have two 45s together. They are called complementary. Complements form 90 degrees. Okay. Now, if I had, again, put my line here, this wide opening, if it's obtuse, you're going to use numbers greater than 90. That's actually 135 degrees. Plus 45 make 180. Okay, that's the full straight line, 180. Those are called supplementary angles. Okay, that's it for today. Don't want to overdo it, Tomorrow I'll see you again for part 2 when we talk about polygons, things that are not polygons, and particularly we'll talk about triangles, okay? So have a good afternoon, good evening, and we'll see you tomorrow.